I was thinking to myself, like, man, this is really technical work. And looking at all
Yeah, it is.
their manufacturing and like
Yeah.
all the research and development, I'm like, how could a
Yep.
person try to get into like aerospace or parts manufacturing? It seems like it's a really high cost to just be like, hey, I've been an engineer my whole career.
Mm.
I want to start my own,
Yeah.
parts, my composite. It seems like there's
Yeah.
still a lot of big barriers. I mean, can you speak to that? I mean, how do some of these
Oh, yeah.
huge airline companies get going?
You need a lot of cash, and you need to have a customer that's willing to work with you as you put this thing together. Right. Virgin Airways was another example. There's been a lot of like airlines and aerospace companies. Sierra Nevada Corporation is another one that comes to mind. So there's a bunch of companies that have kind of quasi garage built out, but it's hard because you just always need more and more cash to get to the next project.
Hmm.
And in a sense, uh, it's almost to the point. Well, if you think about so my wife and I were talking about this the other day about how few aerospace companies there are today, even from when we first joined. When we first joined, we were working for General Electric, and General Electric had an aerospace division. Well, they don't have an aerospace, and they sold it to, at the time, Lockheed, who then merged with Martin, so it became Lockheed Martin, and that was in a realm of about 3 years that all that happened. And the consolidation, because all the projects, we were working on spacecraft projects at the time, those spacecraft projects cost so much money, and if you
Hmm.
had a bad launch or you didn't get into orbit, it's so much money you couldn't, as a small organization, you couldn't really afford it to go wrong. Jeff Bezos, Elon Musk, those kinds of financial wherewithal, Bill Gates, Paul Allen, those kinds of people can afford the risk and could lose the money and still go out to dinner at night.
Yeah.
There's a difference, right? And it's so, if you think about I know they're just celebrating the, was it the 50th anniversary of it's a celebration, I suppose, of the Apollo 13 launch and the problems they had on Apollo 13. And if you kind of thumb through some of that information, you're like, wow, that's really rudimentary compared to if we were building the same exact thing today, and we are trying to build basically similar things today. We're spending so much more money on it, and it's so much more complicated than some of the stuff we were building way back then. But it's also a lot safer, which is the
Hmm.
point, right? So even though the process is the same, we have added a lot more capabilities, like the SpaceX launches where they're landing vertically, right? They'll be able to reuse a lot of the equipment, and which was an overall cost savings, but the complexity and the risk involved with that, because that could have not worked. And if it didn't work, well, Elon Musk is at risk, but he's not at that much risk, in a sense,
Yeah.
because of all the money he has. So yeah, so if the rocket, and it did, right? If you remember some of the early rocket launch landings, where it would just tip over, or they're trying to let it out on that barge out in the ocean, and it wouldn't quite do it, or it was too windy, or and all the things that play into that. Um, you need big companies with ability to swallow it, and even Boeing has really struggled in some of these launch things lately, because the PR wise, in a publicly traded company, it's hard to have big mishaps, right? And so I do see that sort of the Bezos thing makes sense, in the sense that if one of his little experiments goes wrong, okay, it's on him.
Yeah. Well, and, as you start to wade through what, Camfit says that they are one of the very few people that can make really good quality
Yeah,
composite and metal parts.
yeah, true.
You can probably see why. Like if you're in the metal part industry and that's your niche, and you say, okay, we want to get into composites, there's probably just a really big
Oh,
startup cost to then get all
huge.
that tooling and
The
technology
autoclave,
and yeah, all that
yeah,
stuff.
it's
And then
expensive.
to have people that know how to do it, and you got to find. I mean, it seems like that's why
It's a
everyone
whole
starts to
set of
get into
training.
their little niches, and
Yeah. Oh
um,
yeah.
so yeah.
Everybody on the who's actually working in the factory there has expertise, and it's hard to find people who have both expertise in sort of metal and on the composite side, and on the engineering side. You hear it's the Beach Starship, uh, uh, black aluminum airplane thing that happens where we make a decision that everything's going to be made out of composite, or it's going to be made out of metal, The reality of the situation is the best solution is a combination of the two, which is where CanFit is. That you can make metal parts because they're just lighter. They can be lighter than carbon. Carbon fiber is heavy, right? But carbon fiber you can orient where the strength is in a piece of composite. In a piece of metal, you can't really do that. So every part, and depending on what the structural loads are and what you're using it for, a design decision needs to be made whether it should be made out of metal or should be made out of composite. In a place like CanFit, you can make those decisions all the time because you can do both, right? So you probably have the best overall solution when you put all these pieces together. You probably have the best product overall because you made those trade-offs. You didn't have to do one or the other from the start. You can make the best decision for the part, for the assembly, for the whole aircraft up front, which is going to
Yeah.
lead to a better end product.